Hello everyone, my name is Timothy Lee Grant, and today we are going to be reviewing a problem that we did yesterday, which was number 841, keys in rooms. Now the problem with this is we were able to successfully solve the problem, but we're here to learn how to do depth first search. And the way in which I did this problem didn't seem to me at all to be a depth first search kind of problem. And so this is a wonderful opportunity for us to try to figure out like, okay, how exactly can this problem be classified as a depth first search kind of problem? And maybe give us more insight into, okay, well, maybe our minds were too narrow and we don't kind of see how we're able to apply this algorithm to more broad problems. So first, before I try to go and investigate how this is a depth first search, let's try to figure out, refresh ourselves, what's going on with this problem, how we solved it. So reading the problem statement, it goes like this. There are in rooms labeled 0 to n minus 1. So we have an array, and each room, there's in rooms there in this array or this list, and each of those rooms is just labeled by its index. Pretty good. And all of the rooms are locked except for the room 0. So all of the other indexes except for the 0th index is locked. So you can't go and visit that room or that index of the list. Your goal is to visit all the rooms. However, you cannot enter a locked room without having its key. Okay, so we want to visit each element in this list, meaning visit each room, and it doesn't matter in which order. We could go to the first room, then the last room, then the middle room, then the second to middle room, and so forth. It doesn't matter which order we go, but we do want to visit all of the rooms. Okay. When you visit a room, you may find a set of distinct keys in it. So I'm going to go into room 0, for example. That's the first room, and room 0 is always unlocked. So I'm going to go into room 0, and in each of the rooms, there is going to be a set of keys. And these keys are going to be like 2, 2, 3, 5, 5, 6, 8, 3, something like this, or nothing. And what that means is each of those numbers, each of those keys allows me access to that index of a room. So if I go to room 0, first off, and in that room I get keys 1 and 8, that means I am now allowed to visit rooms 1 and rooms 8. Then when I go visit room 8, room 8 might have more keys, or it might have no keys, and then that allows me to get access to those different rooms. Okay. Each key has a number on it denoting which room it unlocks, and you can take all of them with you to unlock the other rooms. Given an array rooms, where rooms of I is the set of keys that you can obtain if you visit the room I, return true if you can visit all the rooms, or false otherwise. So our ultimate goal is to return a true or a false. True if we can visit all of the rooms, false if we can't visit all of the rooms. And then they give us some examples right here. So rooms, and now this is room 1. It contains one key, or this is room 0, which contains one key, and that is to room 1. Okay, where is room 1? That means index 1 right here, and that contains one key, which is 2, so that gives us access to this room. This room has access to key 3, which is this room, and this room has no keys. So we were able to visit each room, therefore we return true, which is what it says there. And then here's an example where there's multiple keys. Okay. So let's go and investigate the method which I used yesterday. And I did a video where I was struggling through this problem, trying to figure out any solution. and trying to work through the problem by myself without ever seeing this problem. So now let me go and look at the solution which I gave and show you guys, like, I don't feel this is anywhere close to a depth first search algorithm. I don't even think it satisfies like a graph traversal algorithm. Okay, so let me show you how I did it. Let me minimize myself. Okay, so we come here, and right off the bat, we don't see a recursive call. So normally, the way that I do a depth first search is I'm going to have a node, and this is going to be the root node. And this root node is going to have in it one pointer, no pointers, 2 pointers, or some pointer variable. So in a binary tree, it's going to be like root, and then it's going to have left and right child, which point to other nodes. And so I just do a recursive call until I hit a base case, and that base case is normally when there's no, well, for depth first search, it would always be when there's no more unvisited nodes to go to. Once I've reached a node that has no connected uh, no connected children or no connected neighbors to it, then I say, okay, I've explored all I can along this path. I'm going to break my recursion, go back to the node that I was just at, and then I am going to see if that node that I was just at has any unvisited nodes. And if it does, I'm going to continue to explore. If it doesn't, I'm going to keep recursing back up until I get to the calling or the initial node that I started at. And if there's still nothing that is unvisited, dust myself off and I'm done. So that's normally how it goes. In a tree, you just traverse, okay, you go all the way down as leftmost as you can go, then you pop back up to the next node, and then you go right, and then you go pop, 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 pop. Okay, but this one, I'm not doing that at all. There is no recursion going on in this solution whatsoever. In fact, this reminds me more of kind of like a breadth first search, because now let's think about how we use the breadth first search, and then we'll investigate how I did this problem, and then I think it's more clear why it feels like a breadth first search. So a breadth first search, as opposed to a depth first search, a breadth first search, you want to stay at a node and you want to visit each of the connected nodes which you're currently at. So you go visit this one, then you go visit this one, then you go visit this one. The way that you do that is you use a stack. So I say, okay, I have my current node that I'm at. I'm going to add each node. Actually, you use a queue, sorry. So I'm at my current node. I'm going to look at each of the connected nodes, and then I'm going to add each node to my stack, or queue. There we go. Keep misspeaking. So you have a queue, which is just a line, and you put in each node that you see, and then once you've put all of the nodes that you've seen in this queue, then you say, okay, well, now I'm going to go to the next value, which is in the queue. So I'm going to pop up here, and then I'm going to go to that node and then visit all of the connected. And then I'm not going to stay at this node. Actually, I'm going to pop back to the node that I was just at and continue until I visited all of the nodes which were connected to my original one. And that's how you kind of get that breadth first kind of fungus action going on. You use a queue, And normally it looks very similar to what I did here. So let's look at how I went and tried to solve this rooms and or keys and rooms problem. Okay, so first thing, if there's no rooms, then I just return true because I say, okay, I can visit all the rooms. There are no rooms. So now, if I get to this point in the code, I know that I'm guaranteed to have a room. And I think actually there, does it explicitly say, okay, so it does explicitly say that that it can be no rooms. So now I know that there is a room. So I am going to declare a list, which is keys and vowels. Okay, so then I am going to take, what I want to do is I am going to take this keys, which is a list of all of the keys that I currently need to process. Now, this is almost identical to that breadth first search uh, uh, queue that I was talking about. That's a queue. This right here is a queue because I'm looking at the first room. I have access to the first room. The first room is unlocked, so I can take every single key that is in this room, this room 0. I can take every key and then add it to my queue of nodes that I am allowed to explore. So that's exactly what I do. I just go in here and I say, okay, so val is, now let me kind of just walk through this a little bit. So like rooms of 0, what is that? That is this right here. It is a list 1, 3. Okay, so I am visiting this node. I am adding uh, I'm adding 1, 3 because then when I come here, I do 4 val in vals. So vals is 1, 3, and then I append each of those values. So I append 1, and then I append 3. So now keys contains 1 and it contains 3, which are the nodes which I am now allowed to process. Okay, cool. So now what I do here is I just create a set. So this not visited, it's just a set. And I add each of the indexes to this set. And the reason why I'm doing this is because I want to check if I've visited every single node or every single room. So I want to add the label, which is the index, of each room that I need to visit. And then if my set is empty, I know that, hey, I did visit every single node, every single room. If there's still values in this set, that means I didn't visit each node. Okay, and then I remove the 0th element because you can always visit the first element, and we visited it right here. This is kind of us processing the room 0. Okay, cool. So now, just like breadth first search, we use a while loop until our queue is all used up. So while we still have keys, which represent what? That a key represents a room which we are allowed to visit. So that means a room that we still need to visit. Okay? So what do? So keys and key singular is different. So what we do is we take keys and we pop. So we just take the element off of the queue and we process this. So now I am going to have keys.pop So we take this, right now, keys contains 1 and 3. I pop off 1, and now key contains 1. So this means I now have the key to room 1. So I can now process node 1. I can visit node 1. I can visit room 1, which is precisely what I do. So now, if key in not visited, what does this mean? So this is kind of inverted a little bit because this is actually not visited. So not visited, I want to know if I have visited it. If I have visited the node, I don't want to do anything. If I haven't visited the node, I want to visit it, process it, and if not, then I just pop right back up to keys. And if I still have a key, or keys, if there's still keys in my queue, then I just take the next one, see if I visited that one. If so, I take a next one out, right? And eventually I'm going to get to nothing. So, but if I haven't visited the room, okay, well then let's process it. So, not visited dot remove, and then that key index. So that I'm just saying, take that room and this set of not visited and say, yep, I visited it now. Okay. Then values equals rooms of key. So this one is, these lines of code here are kind of connected. What this is going to do is I'm going to get, like, let's say that key is equal to 1. So now I am going to get this array, or this list right here, and values is going to be a list, which is 3, 0, 1. Then I'm just iterating through that list, getting the each value in that list, 3, 0, and 1, and then appending it to keys. Now you notice 0, I've already visited room 0, and I'm currently visiting room 1. So what's going to happen in that case? Well, I mean, this line right here is going to block it, where 0 is in not visited, or sorry, 0 is not in not visited, so we're not going to trigger here. And also, likewise, 1 was just removed. 1 was key right there. Okay? And then at the end of this, there's two options. Either my set, which is not visited, is empty, which means that I have visited all of the rooms, or it is there's still some elements in there, which means I have not visited the room, so I just return the negative of that. So you can see this is identical to how a breadth first search works and how you normally go about doing a breadth first search. So I am going to be now just taking my solution and trying to figure out, like, hey, what's going on? So let's see, our trusty friend, Mr. Copilot. I am trying to understand how my solution is a first search. I am doing problem, and what was the problem? It was 841 keys and room. 841 keys and rooms. And this problem is part of the depth first search category, but my solution works, and it seems to follow a first search methodology. Okay, let's see what Copilot has to say about this. All right. Your solution does indeed have characteristics of both depth first search and breadth first search. And the primary difference lies in how you manage the keys list. Okay. So, keys list, which is right here. This is our queue of nodes which we have access to. So it's the seen but not visited yet or processed yet, right? So if I'm at this node, I see this node, I see this node, I see this node, I see this node. I know about that these nodes exist, but I haven't actually visited them and processed it yet. So it's in my queue waiting to be processed. Okay, so that's the difference in this or between the depth first search and the breadth first search is how we manage this keys list right here. Okay, now breadth first search or depth first search. Depth first search explores as far down a branch as possible before backtracking. Yep, that's just like in the example of you have a tree here, so a binary tree, you have a node right here, then you go left, 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 you go all the way down until you can't go down any further, then you pop back up to the next one that you just saw, and then you say, is there any other connected node to this one? You say, yes it is, it's right here, then you continue to try to explore all the way down on this node, all as far down as you can. If you can't go down any further, you just pop back up and you keep popping up. And each time you pop up, you look at the node that you're currently at and say, is there any other node which is connected to the one that I'm currently at? And then you go as far down as you can, then backtrack up and then look. Okay. In the context of your problem, if you use a stack to manage the nodes / keys, you effectively perform a depth first search. Your code achieves this through the use of keys.pop, which retrieves the most recent. Oh, okay. I think I see what's going on. So when I am right, where is my pop? Oh, where's pop? Here it is. So, what does this mean? This means pop, I think actually, I have a list and it takes it from the, I hate how my screen is backwards. This to me, this is my right hand. So this feels like the last, but this on the screen looks different. Anyways, so pop will take it from the last element in this array, whereas if I'm implementing a queue, which is a breadth first search, I need to take it from the first element. So actually, this doesn't achieve a breadth first search because I'm not taking, as I said, I'm not taking one, I'm actually going to be taking 3. Okay, so if I wanted to implement a breadth first search, I would just have to take like pop and then index 0, like that. Okay, so that kind of that kind of explains the confusion which we were having. Your code achieves this by the use of keys.pop, which retrieves the most recent added key first. Okay. So depth first search, I'm going to continually try to search those connected rooms which I'm currently at. So I have a list and I add ding, 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 all of these, and then I am at this current node. I'm at this current node, and this current node is connected to two elements. Let's say, and then I go ding, ding. So now I just, instead of drawing from way up here, I draw from the very back, the ones that I just added. Now, just added means depth first search because depth first search, you explore all of the nodes which you have most recently seen. Breadth first search is different. You visit the nodes in the order that you saw them. So if I have a graph here, I wish that this problem had a little tree graph. Let's see. I can just go here. Just do plus, and then binary tree graph. So like breadth first search, I'm going to visit 1 and then I'm going to see 7 and 9. Okay, then because I saw 7 first, I'm going to go look at 7 and I'm going to process it. What does process mean? It means look at all of the connected nodes. So look at this node and put it into scene at the end of my queue, right? End of my array. Then I'm going to put 6 in there as well. So now I have in my queue 9, 2, and 6 in that order. So then, now the question comes, do I visit 9 now, or do I visit 6? If I visit 6, look what's going on. I'm exploring all of I'm going depth. I am going as far as I can down this graph. That's the most recent. Okay? That's depth. If I visit if I visit in the order that I saw it, which is 9, that's breadth first because now I'm going to visit 9 and then I'm going to put this 9 into my array. But am I going to explore 9? Nope, not yet. It's just in my known nodes. I still need to go and explore 2 because that's the order that I saw it. So breadth first search, I'm going to start here, then 7, then 9, then 2, then 6, then 9, then 5, then 11, then 5. Like that. Whereas depth first search, I'm going to come here, come here, come here, come here, then go back up. And then now I look and see if this node that I'm currently at has any other ones. Yes, it does. Then I'm going to come here, pop up, then here, then pop up, pop up. Does this one have any other nodes? Yes, it does. Then I'm going to come down here and do depth. Okay, so that's why here, if I pop from the back, that means the one that I visited, or that I saw the most recent, which is going to be depth first search. So I'm popping, I'm looking here, and then I'm saying, okay, I'm going to come and add 7 and 9 into my list. Then I'm going to take the one that I most recently saw. I most recently saw this 9. Then I'm going to process it, and I see one node. I'm going to put this into my list. Now, which one do I process? The one that I most recently saw, which was just this one, this last one. So I go and I visit that one and I process that one. I say, is there any other nodes in here? Or any connected nodes in this one? Why, yes, there is. It's right here. So now I have two in my list. I have this node and I still have this node. Which one do I visit? I visit the most recent one. So I visit this one. I visited this path right here. Then I say, okay, now what is connected to this? It's nothing. So I'm going to go and I'm going to visit the most recently seen node that I haven't processed, which was what? 7. This is a depth first search. Whereas if I took it from the very beginning, I said I want of my array, I want the uh, elements in the order that I see them. I'm going to come here. I see this one and I see this one. Well, I saw this one first, so I'm going to go and look at, or I'm going to process this. Then I see this one and I see this one. Okay? But I saw this one first, so I'm going to process this 9 first. So I look and I see this node. Now, I don't process it immediately. I say, wait, that you need to be in your order. Well, this is the one that I saw. So I process this one. That's when you take it from the beginning of the array and you just add elements as you see them to the end. So, long story short, this is actually a depth first search, even if I didn't implement it using the recursion that I normally associate with depth first search. That is pretty cool. I like this. And I knew that you could implement a depth first search using a while loop. Like, I knew that there was an iterative method, but I didn't think about it. And I didn't think about how it actually worked. Now, going through it, working through it, looking at the actual graph and visualizing, okay, well, how would a queue work versus how would a stack work? Stack means take it from the back, queue means take it from the front. And how is that actually going to implement breadth first search versus depth first search? Now I have such a more clear understanding of these two concepts and what the change actually does. And so that's why I knew that this was going to be a very fruitful video and that there was going to be a lot of learning which is done and understanding which is done. So I wanted to take everyone along in this journey because that's kind of what I'm doing. I'm making a video every single day solving LeetCode, trying to document kind of the process at which I'm using to improve myself and get to understand these concepts. So if that's something that you enjoy, please subscribe to this video or to this channel. My name is Timothy Lee Grant, and I will be back tomorrow with a new LeetCode video. So thank you guys so much for watching this. Wasn't this cool? I don't know. I kind of like this because I knew that there was uh, an iterative way to perform a breadth first search, but I just hadn't actually gone through the thought process of performing it. And at the beginning of this video, I didn't know that this is the path that we were actually going to go down. I thought that this video was going to result in me saying, oh, yeah, we did a breadth first search. There we go. That's cool. And then I was going to go to Copilot, and Copilot was going to tell me, you did a breadth first search. Here's how you do a depth first search. And then it was going to give the recursive method or something like that. That's what I thought that this video was going to be. But then it turned out to be something completely different. And I think we learned much more than what I had initially thought that this video was going to be. Awesome. Amazing. So anyways, thank you for watching this video. I hope you guys have a wonderful day, and I will see you tomorrow.